Good evening. Today I will present my project. And this project, the main idea is to simplify the system to have independent finger movements. Usually used electromyography. And for this project I will use optical myography to distinguish the movements. So first, what is used nowadays? So electromyography is used nowadays. And I have some topics here. For example, it's needed to use electrodes on the skin surface to get the movements. It's difficult to filter the signals because you have noise and you have too much signals from muscle. So you have to treat the data, and this is very difficult. And independent finger movements are difficult to get because of the noise and the multiple signals coming from the muscle, and require many math process, and noise generation, and requires complex algorithms. So, for example, here's some examples of data analysis. And as you can see, you have the brain, you have the neurons and the muscles. So the muscle will generate some electric response, electric signal, and this is the raw image signal, and you have decompositions, and then you can filter the signals. So to treat this data is very complex. And I have other examples here. So you have to work with frequency and time, you have to work with the impulse, and treat all this data. So the main idea is to simplify this process by image processing. So what's the idea? My idea is to use the optical myography. So the use of a camera to capture the skin topography modifications by identifying the outlines of the image using the contour function in MATLAB. So a camera will capture the movements. So when you do the movements, I see that there is some change in the forearm. So some cavities will form here. So by this difference, you can check what finger is moving. But I will explain more later. And for this, I made the use of bracelets that emit light beams parallel to the forearm to form shadows due to the modifications on the skin surface, making possible to recognize different patterns due to finger movements. So I will use a light bracelet, so it will emit light, I will show here. And this light is responsible for enhancing the shadows formed by the cavities here. So when you move, there are different patterns, and you can recognize this pattern to recognize the finger movement. And the use of this image to compare to a preset pattern defined by the user as a default for a movement check and generate signal for a future bionic hand. So treating the signals and using image matching, you can distinguish the signals and then send to a future bionic hand. So I already started this project that I will use also for my master thesis, and I produced some device. So here I produced the battery case, but everything by cardboard. So this is the battery case, and here is the LED that I use in this bracelet. So I use 3 pairs of LED to emit this light. So I assemble everything in the card paper with the battery. So I soldering the LEDs in parallel, in series, and then they will emit the light parallel to the forearm to generate the shadows. And This is the bracelet in my arm. So I just turn it on and then generate the light. So this is the bracelet, turn it on. I have a button to turn it on. This is a black box, so there is a hole here. I don't know if you can see. There is a hole here. This is cardboard too. And you can, this is just for the first test. You can put your arm, and then I position the camera here. And this black box is because I don't want the environment light to affect my measurements. So it has to be this, the same measurements every time. So the only light source I want is from the bracelet to keep it, to keep the pattern. So here I open the box, you put your arm, close the box, put the camera here, and then we can get the image. And here the bracelet. So how it works. So here I have the bracelet in my arm. So every time I move the fingers, this pattern of shadows will change. So by this change, I can identify what finger is moving. So at first time, in the future bionic hand, wearable case will be used. And for example, I can preset what is the default pattern. So if I move this finger, I just set this pattern for this finger. I move this finger, I set the pattern for this finger, and so on. And then, once the preset is done, every time you move the finger, the system will, using a match processing, image match processing, to check what pattern is being produced in our arm, and then generate the signal. So, for example, here I have the index picture. So when you move to index, and I have the middle, so there's a little bit change. And when you move your ring finger, there's another pattern. So this is very soft change. That's why I have to use the function of MATLAB that is the contour F. So if I use this function, I can get the outlines of the shadows, like a topography. So then, applied, I get this image. So this image is for the index, and this image is for the middle finger. So the pattern changed. And this one for ring. The pattern changed again. So each finger has the unique pattern. By this pattern, I will identify the finger movement. I made a simple video to explain how it works. So let's see. Sorry. So when you move the finger, the system just captures as a preset. So you move again, and the system will check if it's the same or similar. And then now the system compares with the image and check if they are the same or at least similar, and then recognize as a signal for finger movement or not. So by using this technique, I can identify the finger movement and send to the bionic hand. So after this, I have a matching process. So first, I just convert this contour to gray because I need to convert it to double. I was thinking about to convert to binary, but I have to do some tests to check if it will work. So after convert to gray, I will do a subtract So when I subtract one image from another, I can compare the difference between the images. So every time you move the finger, the system will capture this image, compare with the preset by subtract the image, and check if they are equal. So for example, this is the image 1 minus the image 2. And you can see many lines here. That is the difference between the images. Here, it's 0, 1 minus 0, 3. For example, index minus ring, just to check if there is difference. And here, this is the 2 minus 3, and there is difference too. And as a test, you can see here, here's better. So all these lines is the difference between the images, the different parts. And here, it's all black because it's the same image minus the same image. So it's black, so there is no difference. When I convert it to double, I can get a matrix. And by the average of the matrix, I can get 0. So if it's 0, the images are equal. If they are equal, it means that it's a signal. So the software will check if the images are equal. If they are equal, I can recognize that signal. If they are different, this is not a signal for this finger. So this is the main goal of my project. And so what the other goals for this project? Is the development of a bionic hand with a wearable case that will work using optical myography combined with a simple EMG system. Because this system is to use by only to identify finger movements. And the EMG would be used for the whole, to move the entire hand, for example. Because I can do this in optical myography, but I didn't test, so it can mix EMG and optical myography. So for detailed functions, use the optical myography. And the other goal is to simplify the system as much as possible to keep it cheap, and so anyone can buy it. So this is my main project. Thank you. That's a question. Okay. So, any question?
So how will you solve if there is small difference when you retake the picture? After we record the correct characteristics of each finger, and then you're gonna compare.
Yes.
Right? But after you take off the bracelet, and then
no. For example, you will use the wearable case with the bionic hand. So it will attach to the forearm, and then once you wear the case, the bracelet is together. So you put the arm here, and the bracelet is together. So generating the light. Yeah, the light source is already inside. So, for example, for first time, the user will set the default pattern. So once you wear the bionic hand, you have maybe some button or touch screen. You will say to the system what is the default pattern. So when I move this finger, I press a button and say to this, and I will tell to the system that this is the pattern of this finger. So, and it will be stored. And the same for the other fingers. So once the images are stored, the camera will have will analyze in real time. So the camera works in real time. Every time you move, the camera will capture and all the time comparing with the stored image. If you move this, the camera will recognize this pattern and compare with the 3 patterns you have. If one of them match, it's a signal for this finger. So then I convert this for a signal to the bionic hand and move the finger. So that's the main idea. So it's much less math process, and actually nowadays the bionic hands doesn't have independent finger movements. I tried to research on the internet many kind of bionic hands, and the most advanced doesn't have the finger movements independent. So they have, for example, pinch and the whole hand, and some movement for entire hand. But if you want to move only these fingers, you cannot do this. So they have some presets that you can do this, but it's very, very complex because you need to filter all the signals from muscle, and it's very complex and require many computational importance. So the main purpose of this project is to simplify the system, and then you can get it to very fast and for independent finger movements. Because the last bionic hand I saw costs about $30,000 and doesn't have independent finger movements. So sometimes to pinch, they just set a button, and these fingers will do like this, and it will set the fingers like this. So when you move the muscle, they recognize the signal, but they only do this for pinch something. So this is an easier way to get the independent finger movements. What do you think?
But I think there's a reason for people developing the machine that does pinch or grabbing. The point is, we don't really have to move fingers independently.
Yeah.
In your daily living.
Yeah. It's why I will use some. This is actually a complement because, for example, to move the entire hand, you can use EMG. It's much more easier because you don't have to filter too much the signals. You have the muscle signals, so you can do. You can close your hand very easily, and you can move your hand very easily because of the muscle activity. But when you try to get the finger movements independently, you have to filter all the signals, all the noise. You have many groups of muscles, and all the signals came together. So you need to separate each signal to identify what is responsible for each finger. So usually they don't do this. So the main purpose of this project is to complement a bionic hand to have independent finger movements. And for the entire hand, I can use this system too, but for pinch, maybe we need to use the EMG or for entire hand. So we can combine together these two technologies. Because just to complement the EMG, because it's not possible to get independent finger movements on EMG. So that's why I thought about this project. Any questions? Okay, thank you so much.